Hello everyone, my name is Malcolm. Today I'm going to introduce IEI Mustang-F100-A10 acceleration car. Mustang-F100-A10 is an Intel Vision accelerator designed with Intel Area 10 FPGA and is powered by OpenVINO Inference and the Neural Network Optimization or OpenVINO Toolkit. Here's the outline of this presentation. Today, more and more applications implemented by AI method not only to reduce the human loading, but also increase the accuracy of the application, from factory automation to smart retail and surveillance and also medical diagnostic. Before we introduce our new product, let's go through a little bit basic knowledge about the training and inference workflow. There are two parts of the deep learning process. The first step is the training. The training is learning from the existing data. The second part is the inference. Inference is predict the new input data. So the workflow will start from the training data set. We prepare the training data set and put that into the deep learning topologies, such as AlexNet and GoogleNet. Then we train the training model. After we got the train model, we will put the train model into the inference engine. Then every time the new data set coming, the inference engine will issue the deep learning inference that get the new test result. Today, server-grade systems have done a very great job in the training process. However, how to design a real-time edge device is a critical task for today's deep learning applications. And that's why we will introduce the Mustang-F100-A10 acceleration card. The first feature is the compact size. It's a low-profile, 2-slot compact size acceleration card, which means you can install that into your server-grade IPC and your compact IPC system. The features of multiple cards allows user to add more acceleration card to increase the inference performance for your system. The extremely low power consumption is very suited for the edge deep learning device compared to the existing solution. Let's say the conventional GPU power consumption is near 100 or even 200 watts. The low latency features means with the FPGA structure design, it's very suited for the real-time inspection, the task. And the OpenVINO Toolkit, with OpenVINO Toolkit, it's very easy for a user to deploy their inference. Another feature is high flexibility. We know FPGA can, one advantage of FPGA is high flexibility. And in this case, for the Mustang F100-A10, you can upload the optimized bit stream from the PCIe interface. Let's say you want to use the topology of the ResNet or GoogleNet or AlexNet. It includes each different optimized bit stream for each different topologies. Here's some specification of the Mustang F100-A10. It's using Intel Area 10 GX1150 FPGA. The interface is the PCIe Gen 3x8. The operation system is Ubuntu and the CentOS, and the Windows 10 will come soon in the end of this year. So the form factor is a compact size, high half-length double slot, and it got the dual frame for the cooling system. And there's a power connector, which is preserved for PCIe 6-pin 12-volt external power. And the current support topology is SNet, CocoNet, and LNet, SqueezeNet, VGG, and ResNet. So you can see from the right side picture, the performance is 90 times higher than the system which only have the CPU. And the power efficiency is also 5 times better than the system which only use the CPU. So let's talk about the OpenVINO Toolkit. OpenVINO Toolkit allows users to deploy the deep learning inference for the different Intel accelerators architecture, from CPU, integrated GPU, to FPGA and the BPU. Intel OpenVINO Toolkit includes the model optimizer and the inference engine. Model optimizer can optimize the pre-trained model from the famous frameworks such as TensorFlow and MSNet and Caffe. Then the inference engine will execute the optimized model from the model optimizer. Also, you got the optimized computer vision library, which means the OpenCV 3.3 is optimized for the Intel architecture. And the Intel Media SDK is for you to handle the video codec process. And also OpenCL and FPGA runtime environment was included in this package. Here's some Intel platforms description. First is the CPU. It supports the 6th to 8th generation Intel Xeon and Core i processors. And for the integrated GPU, it supports Iris Core and Intel HD graphics. And the FPGA, in this case, the Mustang-F100-A10 is using the Intel Area 10 FPGA. For BPU, it's the Intel Movidius Neural Compute Stick. And let's talk about some OpenVINO Toolkit workflow. The first step, you can use the trained model from the famous framework like TensorFlow, Caffe, and MSNet. Then use the model optimizer to optimize the trained model into a IR file, which means intermediate representation. Then put that into the inference engine. So from the whole process, from the left video stream, the first step, you can use the video decoding using Intel Media SDK to do the video decode. Then you can do the image preprocess, which means you can use OpenCV or OpenVS and doing some morphology like dilution, erosion, or you want to do the motion detection. And after the image process, we put the input image into the inference engine. The inference engine will come out the deployment result. Then after that, the deployment result will pass to the image post-process. Again, we use the OpenCV and the OpenVS to do the overlay or test on the picture. Let's say you want to highlight the inspection result, and you want to put the test on the inspection result. And the final step is the video encoding. Again, we use the Intel Media SDK to do the video encode, then pass the video stream to the other source. From the right bottom side, it indicates the Intel accelerator, which means you can switch your different architecture from CPU, integrated GPU, FPGA, and the BPU. Here's some examples about the deep learning inference. There's the image classification and the segmentation, and also the license plate recognition, it's the LPR. For more detail, we will suggest you to visit the official website of OpenVINO Toolkit. they are doing a great job for the how to get started and have many code samples and even provide pre-trained models for you to do the evaluation. Here are some industrial AI inference that IEI offers for the AI inspection. From the FAST200 FAST PPC series to Tank-A70 AI and the PET400 AI and the RIG500 AI. The FAST200 and the FAST panel PC is extremely suited for the environment which need high dust and high waterproof situations, let's say in the food industry. For the Tank-A70 AI, here's the a snapshot from the Intel website. It using Tank-A70 AI combined with Mustang acceleration card to do the inference applications. So with the rich I/O of Tank-A IoT development kit, it's especially suited for the different industrial tasks. And the OpenVINO toolkit was pre-installed in the Tank-A IoT development kit. So once you gather the Tank-A70 AI and the Mustang-F100-A10 car, you put that together, then you can start your deep learning inference right away. The RIG500 AI is designed for the full-size deep learning accelerator, such as NVIDIA Tesla series, and the PET400 AI is designed for the half-size acceleration card, such as Mustang F100-A10. And both of those series are preserved by 4 PCIe slot, which is used for the 10 gig frame grabber to get the information from the other device. So here is our quick demo. The environment is including Tank-A70 AI, Mustang F100-A10, and our OS is Ubuntu 16.04. We're using OpenVINO Toolkit example, the topology is SNet, to doing the object classification task. So let's start from the installation of the AI toolkit. So here is the box of the Mustang F100-A10. Let's open that. After we open that, you can see there's a quick installation guide show you how to transfer the bracket and how you install your acceleration card into your systems. And here's the Mustang F100-A10 card. So in the front side, you can see there's a switch, which means, and there's a LED. So it indicates the different car ID when you have a multiple car situations. And the rear side, there's a 6-pin 12-volt power connector. It's preserved for the different system configuration. But actually, for the Tank-AI development kit, the PCIe slot provides 75 watt already, so you don't need that connector for the Tank-AI system. So the first step, we should open the top cover of the tank system. Then we will put the car inside the tank system. Then close the top cover. So we can start to our deep learning demonstrations. In this demonstration, we use the Tank-A70 AI and the Mustang-F100-A10 acceleration car. The inference deployed with the AlexNet when we are doing the object classification task. So you can see from the picture of the inspection result, it can detect the everyday life objects such as minivan and some mammal like zebra and tiger, and you can see the throughput is extremely high due to the spatial FPGA optimized design. The throughput is around 800 frames per second. Okay, after today's presentation and the demonstration, hopefully you can learn more about AI Mustang-F100-A10 acceleration car and what can you do with this car in your future deep learning task. For more information, please scan the QR code or contact to AI, and we will try to get you back very soon. And don't forget to press like and share the video. Thank you, bye.